We're very happy to be here to discuss the wonderful world of AI and embedded and ARM-based low-power, low-cost solutions with everybody. So to start, I will briefly to introduce our company, and then I will introduce our solutions based on a Linaro and ARM-based server. We started the company about 2 years ago, just a little over 2 years by now. In 2 years, we taped out 4 chips. Each chip was designed to target different applications or different market. So our team came from 3 different backgrounds. Of course, in Silicon Valley, we design chips. And also, we believe our vision was the next generation low-power AI, power consumption is the key. That leads to the memory problem. So we have the top scientists from the storage and memory industry to also design this chip. So our first neural network-based paper was published back in 1988. At the time, actually, when our chief scientist was a PhD student at UC Berkeley, the title of the paper was named Cellular Neural Network. We call it convolutional today. That paper was cited more than 5,000 times in the last 3-4 years. So our first silicon is already in mass production. So you will see the product based on that silicon starting from this quarter. So we came from a consumer background. We wanted to really make AI accessible to everybody on a day-to-day basis, not just on the cloud. So a couple of years ago, when people talk about AI, we always link that to Facebook, Amazon, Microsoft, NVIDIA, deep learning. But we wanted to make something really low power, low cost that can be used online or offline. That was our mission. That's how we were, what drives us. Okay, let's take a look at the technology. So we make small chips, very, very small. The first chip was 7 by 7. The most current chip is actually 6 by 6. So that enables super low power consumption. But it does produce very good performance in terms of neural network processing. Why? Because we believe today general purpose CPU definitely is not going to be the main platform or architecture for AI. So we believe what is called the domain-specific architecture. Based on that concept, we designed all of our chips to cover the anywhere from the edge to the IoT to the cloud. So what is a domain-specific architecture? In this chip, we have a very unique data flow, pattern data flow architecture. We do not have the instruction set. We do not have the traditional centralized memory management. In this chip, we have more than 28,000 small memory-based cores that enables the high-speed, super high-speed neural network computation. So the difference is that the traditional 0D CPU-based, so we have memory, we have bus, we have software to manage that. Of course, the speed is very slow. Now, when we jump to 1D, which is typically like a GPU multi-core scenario, the power consumption is pretty high, and the efficiency is not as great. So that's how we designed our chip. It's a 2D matrix. We call it MPU, matrix processing unit. So in this little chip, the power consumption is only less than 0.4 watts, but we can produce almost 9 TOPS. So that's just a snapshot of our technology. Next, I will introduce the products. Okay. So we have 4 chips now. 2 chips are in production. One chip was a special MRAM-based chip that we worked with TSMC to co-design this chip. So this chip is very unique. It supports multi-neural network simultaneously. For example, you can do your voice authentication / recognition together with face recognition. Typically, this is very difficult to do. Due to the special material and characteristics of the MRAM, we were able to achieve that. We showed this year at CES as well. So this year, we plan to introduce another 2 chips. One chip would be video-based. I will introduce that later. So we would like to cover the entire ecosystem because from the power saving point of view, for the AIoT, our latest chip is very, very low power, can be battery operated. That'll solve a lot of problems. First, power. Second, offline processing. Imagine your Google speaker or your Echo. When you cut the internet off, it doesn't work, right? But our goal is to design something that really works offline as well. We also work with SocialNext to build the enterprise level of the server based on our chip. These are a snapshot of what our customer have been building their applications based on our devices. On the enterprise level, we have the big surveillance data center, typically, and access entry type of scenario. For the industrial, we work with top manufacturers to do the factory automation and inspection based on our technology. Of course, consumer, smart home, we actually introduced quite a few smart home products with our customers this year at CES. Government. We were selected by the Kyoto government to participate their smart city projects. We were selected as the only one AI computation power provider. So this is a snapshot compares that with the industry leading solutions or the popular solutions. The first one, SPR2801S, is our chip. So we run at 50 megahertz, produce about 2.8 TOPS. Power is under 0.3. So based on that, our top per watt power efficiency is around 9.3. Versus other solutions, our number is much better. 2803S is the latest chip we introduced by the Q4 last year. And this chip produced about 16.8 TOPS at 300 megahertz peak performance. The highest performance we have is around 24 TOPS per watt. So we believe this chip is very small too, so it's around under 10, so it's around 9 by 9. We believe this chip so far is the best power consumption, best performance edge-based AI chip today. So we provide our vision solutions, anywhere from small image classification, simple tasks to all the way to the hardest, semantic segmentation or user-defined detection, video segmentation. And also, we have some special algorithm that allows you to perform the super resolution tasks, and also low light HDR, style transfer, pixel level based, neural network based, not computer vision based, real time. You probably used some online based style transfer software before. Maybe it takes about 2, 3, 4 seconds, depending on how big your image is. We can do around 10 frames per second. This is an example that we took for the low light enhancement. So before and after, and real time too. As I mentioned earlier, this chip also does the latest CNN-based NLP, natural language processing, which is more efficient than the traditional way of using RNN or LSTM. So that's why we can do real-time voice authentication, not recognition. So applications. We work with SocialNext sequencer hardware platform, and of course, running Linaro software. So this is our first generation based on our first chip. This example shows you a fully loaded sequencer server with total of 16 blades built in. So that gives you about 352 TOPS. So here I brought the example, one of the cards. So this side is the SocialNext A11 ARM24 multi-core chip with DRAMs on both sides. And in the back, it has a slot, M.2 based slot with our 4 of our chip built in. So this is the configuration. So on each side, you can put in 16 of those cards. And also, you can select, how many cards you wanted to put in. It's configurable and upgradable. This is the second generation. So the second generation is based on our latest 2803 chip. So it's PCIe-based interface. So that, in a fully loaded configuration, that gives you around 4,500 TOPS. And we believe this solution is the lowest power consumption, highest performance 2U-based AI inferencing server today. In comparison, of course, in comparison to GPU-based. lastly, I wanted to introduce some most updated application scenarios for this particular server that we're building. Last week, actually, the NPEG committee just approved the latest next video encoding standard, which is MPEG-7. So in this MPEG-7, there are separate parts. There are 3 parts that are related to the neural network. So the approved neural network compression is based on VGG16. So part 13 is called the CDVS, Compact Descriptors of Video Search. And 15 is video analysis. And 17 is neural network representer. And we were selected, fortunately enough, luckily, we were participating in this standard since last year. And we are now the committee of this MPEG new standard. That our chip is the first chip in the world that supports this new standard. So basically, it'll give you the capabilities of doing all the part 13, part 15, and part 17. Here is an example of how the visual search is done. We all searched video before, right? So you sit there, you just scroll everything. Oh, you passed, or you sometimes fast forward, sometimes you backward. In this case, you can just take a snapshot or input a frame or a picture of the object that you wanted to search. Then you will see the result. So this search result on the screen is an actual search we've done using our chip from a video. So we try to have visual input of object like city bus, traffic signals, and then we found identical object from the video based on our server, which is the 2801 based, our first generation. This is the street image search. So you can search people, statues, object like umbrella. So the frames on the right side are the actual return image search results. This is the video actually we used. I'm going to skip the video. It's about 20 seconds. So, lastly, our collaboration with Linaro. In the next 6 months, we will work with Linaro to have the integration work in ARM and also we will be building SDKs together and make that publicly available together with our hardware. And also we will optimize the current neural network supported by Linaro to run faster, better on our chip, on our SDK. And we will define the middleware and SDK. And on both sides, we will be supporting we will have the low-level support in terms of hardware on the driver level. And of course, together with SocialNext. Okay. Thank you.